It is a little early, but I am going to start the lecture right at 6 because of the amount of material that we have to cover. So please stand by and hang on. We're gonna go. It won't be too bad. Hopefully I won't put any of you to sleep, but yeah, I'm pretty sure I can stay awake, but I don't. We'll see what happens. All right, I'm going to go ahead and get started. And my clock says 6. I will keep my eye on the attendance, but here we go. Welcome to week number 11, module 11. And we're going to go into data, one part of SQL. That's another component that's pretty important. We call it data definition language. And this is, I mentioned this briefly last week, but this is the part of SQL that you use to impact or, basically your table level entity. And then we're going to expand our conversation on constraints. Generally, you can create user-defined constraints, and we'll get into that. Before I get started, because the extra credit opportunity will remain open in case, I know it feels like it has a due date, but it will remain open until the end of the semester. So, and the way it works, everyone gets essentially credit for it. You get extra credit based on the amount of the challenges. There's 23 challenges. If you do all 23, you get essentially 23 extra points. So it's truly an opportunity to get some extra credit points if you need them. So that's how the scoring is. Everyone actually receives 23 points, by default, but then you get an extra 23 points as you complete any of the exercises. So it's a good way to bring your grade up if you're having issues. Checking the attendance. Okay, so that's the extra credit scoring. If you have any questions or concerns, just let me know. I think a few of you I went through some, and you can always go back and do as many as you want. And most of it is just a review of the modules that we've had in the past. So, all right, let's move from that right into 11.1. Our first topic is creating tables. Yes, you will have the opportunity to create tables. And there's a lot of objectives: list and categorize the main database objects. Pretty important. Review a table structure. We've had this before. We're just going to review it. Describe how schema objects are used by the Oracle database. Schema objects, basically, for our purposes, are those tables and other types of objects, but primarily the tables. Create a table using the appropriate data type for each column. Explain the use of external tables. Now, objective number 5 it's not so prevalent anymore, but you need to know how to access external tables. Usually, especially with cloud databases, etc. Generally, your DBA has already set that up for you, and you really don't have to worry about it. But as an analyst, if you're a data analyst, you need to understand how the tables or schemas are connected. So that's why we're going to cover that. And then the data dictionary to obtain names and other attributes of your data objects is very, very important as well. And you'll see that in a minute. So our purpose up until now, we've selected, updated specific data in existing tables. Now we're going to basically put on our DBA hat. And usually this is the database administrator that's impacting entities like tables. So we're going to learn basically what a DBA does after they've created the schema. The tables that we're using now are very small and compared to real databases. Generally, even in a small company, you'll have hundreds of tables, probably holding hundreds of records for kind of a maybe a little bit of an appropriate example. Google has several schemas. They have millions of schemas holding millions of records. So imagine having to administer that. And we'll look at external tables. Oracle has actually set it up so that even if it's outside of a relational database system, basically the Oracle databases are all compatible per se. We're going to use that term loosely. But in the old days, we're going to talk about flat files. You don't have to worry about flat files anymore. No, as far as I know, no one's really gone back that far, and they're using flat files to create tables. I think we've evolved beyond that, but I will explain that because it is kind of rudimentary knowledge. That's somewhat necessary. We're going to talk about database objects. Oracle can contain many different types of objects, and I'm going to introduce you to the most common ones. Specifically, this idea of the data dictionary, and that's what it is. It's essentially a repository of objects that you have in your database schema, which you definitely need to be aware of. All right, so as far as an idea of what our main objects are, this is a list: table, index, constraint, view, sequence, and synonym. These are our main. There are others, but these are the ones that you'll probably be exposed to, especially as we go into DDL. And some of these objects can exist independently of your schema. Some of them cannot. And you can probably guess off the top of your head which objects can exist outside of the database schema. So some of the objects do take up space or storage in the database, and others do not. Database objects can take up significant storage, and it really depends on the type of data, the amount of data, et cetera. And if it takes up significant storage space, and these are referred to as segments, and this is just general information. Excuse me. Tables and indexes are examples of segments, as the values stored in the columns of each row basically take up, well, a significant amount of physical space, but we have to remember now we have hard drives that are several terabytes. Even when this course was written 10, 15 years ago, that was really not the case. So, excuse me. Okay, sorry for the interruption. Little cough day. So space, in essence, to even now, as opposed to 2015, in 2010, is not necessarily a concern, because I think Oracle is converting some of this ideology to the fact that we do have almost a limitless amount of space. I won't say that tightly, but loosely, it's not necessarily a concern. So I just wanted to mention that. We do talk about in Oracle, because it still is a concern about efficient database management, et cetera. Jeez, I need some water. The database stores the definition of all the database objects in the data dictionary, and you'll see how that occurs. Have you ever wondered how Oracle knows which columns, et cetera? I mean, there's an organization there that's been around for a while, and Oracle is one of the organizations that has really fine-tuned that. So the database looks up the definition of a table used in the query and translates the wildcard, the star, the select star from jobs. Basically, it is a default way to essentially pull out all the columns of the table. And you know that already. So database uses the data dictionary for all. Yeah, I just said that. So I guess in essence, what I'm getting to here, a very useful part of your schema is this data dictionary. You can define many, many things in there. Here's one example. In if you go into the SQL developer and just double click on one of your tables, this is your expanded view of the table. And actually it has different tabs. You can look at things like constraints and models and the data itself. Yeah, without even querying. I did want to point this out. It's not really a lesson because this is all about SQL, but you can pretty much, expand your table. And we're just taking a look at the jobs table here. Column names, data type, a little bit beyond the describe function as far as what you can view in the table. And if you ever have questions about the structure of the table, yeah, just double click on one of your tables in the SQL developer. And that's what I'm referring to here. It's generally referred to as an object browser, and you can actually pull out a ton of details. Data itself, indexes, constraints, without running a query, even though in the back end, there's a backend query being ran just to produce this view. So, all right. So I do want to review the describe command, or the DESC. Remember, this is a very abbreviated view of your table, and you can use this, especially if you're using DML to modify data in the table. You want to run a quick describe and your table name, and as you see, you have general information. I promise I will be okay. Okay, as far as table creation, all right, and let me take a minute to clear my. I will be right back. Okay, I promise I will live. All right, all data in your relational database is stored in tables. Table is the primary entity of the whole ball of wax. So as far as creation, there's certain rules for names and columns. So please take a note of these. The table name must begin with a letter, must be 1 to 30 characters long. Even in our modern day of naming conventions, those are still the restrictions. Must contain only uppercase A to Z, lowercase a to Z, or 0 through 9, underscore, $, or hashtag or pound sign. Those are the only characters that are allowed in a table name. Must not duplicate the name of another object. So it says owned by the same user. So basically you have to be careful, even as a DBA, not to name objects the same. That's why we have all those naming conventions with underscores and all of that. And it must not be a reserved word like table or primary. There are some reserved words, so you have to be aware of that. So it is best to use descriptive names when you name your table, like student. Table should be named students, or people or children. Descriptive. Table names are not case sensitive, but you have to be aware as to how they're named. But I do want to point out that you see here, students is treated the same as students. So this is the one time in scripting where case sensitivity is not an issue. But you may probably want to go with students with all the uppercase, etc. So table names are generally plural. So students to represent students as opposed to student. Creating table is a part of your SQL, basically in the data definition language, which is part of SQL. Other DDL statements are used to set up and change and remove data structures from table, alter, drop, rename, and truncate. And these aren't too unfamiliar. I'm pretty sure you can grasp those. So moving right into the create table syntax. So to create a table, the syntax is you create the table name, and yes, you start with create table. Well, believe it or not, the columns. Column is the name of the column. Data type is the type of data in that column. And then remember that whole default, you can set up a default value for your column, basically to help you if you're inserting data. And like I've always used this date and things like that. Remember the default value. So here's some examples. And you can go back and run these or whatever, but here I'm creating a table called My CD Collection. And our columns are CD number, which is a number, title, which is a varchar artist, varchar, and purchase date, which is a date, and the default is sys date. Excuse me. And then create a table, My Friends, and then all of the columns associated with that. First name, last name, email, excuse me, phone number, birthday, etc. And these are just to describe responses after those tables are created. Jeez, I don't know what's going on with me today. All right, so very simple to create tables, but you need to follow the rules. I do want to point this out. Before I charge ahead, each column is separated by a comma. All of the columns are enclosed in parentheses. So in essence, you have to be very careful that you have an open and closed parenthesis, and the last table is not followed by a comma. So, or last column is not followed by a comma. Pardon. All right, so that's creating tables. I know that really excites you. So, and you're going to be creating some tables and dropping tables and all that fun stuff. I do want to mention, and once again, this is just for informational purposes only, because I haven't run anything like this for 25, 30 years. So it does support another, Oracle, excuse me, supports another table type, and we'll call it external tables. So generally, and I'm gonna summarize most of this. If you aren't aware of a flat file is truly, they call it flat because it's basically a huge amount of data, a huge amount of text, stored in a file that represents a table. And yes, you can run processes to essentially connect to that external table, and that's usually the way it was. Basically, and I'll tell you right now, Oracle doesn't really, you don't really need to do this with an Oracle environment, because you'll rarely see flat files used as tables. And this is just giving you an example of, and you can go back and review the lecture, but most companies will not implement a schema using a flat file. But the whole idea of this being an external table, you can treat it just like it's an internal table. Flat files are much larger than you think, depending on the amount of data. But as suggested by the Oracle Academy, there's a recommendation to cover this material. So the new syntax that I'm going to show you on the following slide is basically how you would organize an external table. And so I'm not going to ask you to run this, but this is actually something that I've ran before, where you're essentially organizing an external table, which is a flat file, so that is a part of your database schema. So we're creating a table, and basically we're adding information to that table from an external table. You will rarely see anything like this in our current database administration scenario, but like I said, we must cover it. All right, I'm going to move right from that to our data dictionary. So, all right, so two kinds of tables exist, yes, in the Oracle database. We have the user tables and the data dictionary tables. Now, the user tables, you've seen them. It's when you look at that little schema that we have running of our little company with departments and employees and et cetera. You can issue SQL statements, so you can write queries to both the user tables and a data dictionary. So user tables, as I said, employees, departments, jobs, et cetera. Data dictionary tables, and yeah, notice the uppercase. It's just to represent that it's kind of a system table, but it's tied to the schema or the data. Dictionary, user objects, user tables, and yes, these are user specific generally for us, since we're all basically the same user to your instance of the database, which I know that's a little confusing, but or the Oracle system that's running all of these instances only sees student 1 or student 01, student 02, the same scenario. So you have access to these user object tables or data dictionary tables. So as I said, these are system tables, essentially. So special Oracle user called cis, basically the system, to make these tables safe from accidentally user. I mean, they're full of constraints, so you can't accidentally drop them or delete data from them. So if an Oracle user attempts to do inserts, updates, or deletes against any of the data, yes, it's not allowed. So there's a ton of constraints. So when you're using data dictionary views in SQL, you need to know the names. So basically, you need to know the names of these views or tables. So, and it's quite simple. The prefix of the object that you're looking for is always the user and then underscore and some type of descriptive name. And XXX is the object type. So here, if you run a select table name status from user tables, then basically you'll see all of the tables that's in our little schema. All right. And, well, I didn't mention the all is all of the tables, basically all of the tables, system tables and user tables. So it's a long list. I mean, this is not all inclusive. So if you ever want to be curious, run that this particular query, you'll see how many tables you have in that schema, even outside of our little employee and plus data, database schema. So if you want to investigate indexes, and then simply select from user indexes. You want to information about sequences, yeah. So this is an example of that. And as you see, there's a ton of information in there. And so things like table owner, and you'll see student, whatever your student is. This is a good way to see what if for some reason you forget, which I'm pretty sure none of you have had that problem. But the one thing I do want to mention again, you all are part of this cloud instance. So generally, you're not going to have a problem with multi-users, et cetera, et cetera. So this is just, once again, user objects, looking at sequences, and notice the naming convention and all that fun stuff. So there you go. In a nutshell, in this first topic, which wasn't too bad, we learned about how to create a table. We learned the data dictionary and how important it is what a table is as far as an object. In external tables, schema, remember, is the whole everything that's involved in our little number of tables. And then a mention again of the default value in your table creation. As you recall, you can set, well, we're going to get to the point where you should be able to understand, essentially how to impact that table once it has been created. All right, I'll pause a second here. Any questions about table creation before we move on to our second topic, using data types? Hope everyone's still awake and not coughing. Okay. All right, so our objectives for topic 2, create table using timestamp and timestamp with time zone. Column data types, create a table using interval. Pardon me. Too many things going on. All right. Create a table using interval year to month, interval date to second, column data. These are just column data types. Give examples of organizations. So yeah, these objectives are interesting, but we know the general data. So these are some of the special cases. Let's just think of it that way. This would provide examples of each, the number, date, and character data type. So that should have been the first objective in my mind, but let's move on. So if you ever travel to another country, you quickly find out that the money in your pocket may not be, well, of course. If you want to buy something, you may need to understand how all the currency is converted. The conversion process is a lot like dealing with data types. Different data types have different types of characteristics, as you probably figured out. So we're going to learn all about data types. Each value manipulated by Oracle has a data type. The values data type associated with a fixed set of, basically all of your data is categorized in a specific data type. And we have three of the basic ones that you normally deal with: char, date, or number, and that's persistent across any relational database. So different data types have different advantages. Columns of a single type produce consistent results, which is why we have it that way. So in a nutshell, we want to make sure that our columns, when you create our tables, are consistent with what the data that we want to store in that column. And no, you cannot mix data types within a column. You get an error mixing data types. So as I said, here's some common data types. The most commonly used data types for character are char, varchar 2, or clob. That's large data. That's something new created by Oracle. Yes, it is actually called clob, C-L-O-B. It's a variable size, maximum 128 terabytes. So that's quite a bit of data. And then number is just number, 38 digits. So that's quite an expansive capabilities. For date and time values, there's date, timestamp, and interval. Interval is not used that much anymore, not at least on the front end SQL, but it is useful depending upon. Well, anyway, there's specific reasons for that. And then for binary values, like JPEGs and special types of files, MP3, MP4 even, you use the raw or the blob. Yes, the blob is an actual binary. And don't ask me what blob stands for. I used to know this, but blob and clob. I think blob is something binary, clob is something char or character. So, but these basically large data type objects. I think that's what it stands for. So if you're curious, and you can Google that or ChatGPT it or whatever. So for character values, it's usually better. Yeah, varchar 2 is your default. And you can use char, but remember the difference between varchar and char. Char is not variable. It's usually essentially a fixed size, which can be problematic. So always use a varchar 2. And varchar 1 does exist, but it's not recognized since it was updated quite rapidly way back. So varchar 2 is your default for char or for strings. Number values, it's the number data type, and you can indicate the number of digits, right side, left side of the decimal, etc. And we've seen this before, so that's not anything new. Date time, once again, the valid or the default date representation in Oracle now did change since way back 20 years ago. Sometimes I can't believe it's 2025, but it's 2-digit day, 3-letter month, and 2-digit year. And the date timestamp data type is an extension of the date. It basically it allows fractions of seconds if you want to, create a granular representation of date and the time. So if you do timestamp 3, allows 3 digits after the whole, which means you're recording milliseconds. You need that? Yeah, possibly in a scientific scenario, but so here's some date time data types examples. So here we're running a create a table time. So we're going to call it time example 1, exact time. That's our column, and it's just a timestamp. And then we're inserting the values, and yeah, this was ran quite a few years ago. Basically the date and the time. And yes, we're looking at several seconds here. So if you want to insert into this particular table cis date, then you get a representation, and then insert into this table cis timestamp. So here are the three values, and this was ran in March. So here's that first value. I just updated it, or back then it's March 25th, or March 5th, excuse me. Here's our cis date, and here's our cis timestamp. All the same date, but different representation of the time. Does that make sense? Does that little example make sense to everyone? Thumbs up. Are we still awake? That's my chance to interact. Thank you. All right. And so you're probably wondering, so if we go through this thing like local time or daylight saving time, or how many hours, epoch time, or well, anyway, so the 24-hour clock or the 12-hour clock. So think about the time value. Of course, this means basically 5:30 in the afternoon. Those of us that have been in the military, yes, we're very used to that. Other individuals may not understand what that 1730 means, but which time zone? So if it's 5:30 in New York or Beijing or Istanbul, etc. In today's globalized organization, which is a big deal now, you need to know what time it is in several different countries, or regions. So you do have that capability. Let's see what we're going to talk about that. So timestamp with time zone stores a time zone value as a displacement from the universal coordinated time. And you probably didn't know what the UCT meant until now, or the Greenwich Mean Time. Same thing, basically the same thing. Basically London. So the value of this date means 8 a.m. 5 hours behind UTC, and that would be Eastern, which would be New York. And yeah, you can drive yourself crazy, but yes, you can use this particular way to determine the actual local time. So here's our example using this time. Our second example of a table, X2, time with offset. That's the name of the column. That's not some special timestamp with time zone. So we're gonna store in here what's the offset from UTC. Remember that. Insert the cis timestamp, and then insert. Basically, this is our table, right? And this is one of our values, and this is a second. Of course, I use March, the current date. So it's a -7 UTC. And then I just forced it to say this is +2. I mean, you can do that if you need to. But basically you can use this to indicate what's the difference between time zones, like we're +2 hours or -2 hours, depending on how you look at it. Right now we're what are we, +1 hour from California, et cetera, et cetera. So don't get too lost in that. It's just another way to represent what time zone you're in, et cetera, using SQL. Another example here, we're creating a table time EX3. First column is timestamp. with time zone, the time zone we're in. The second column is timestamp with local time zone. And then we're going to insert to our columns here these two dates. And what will be returned, basically you'll get the local time. Both values are stored with a time displacement of -7, which is basically our, well, we're mountain now, but if we have a user in instrument bool that will execute this, it will come out different. Because we know that Istanbul is 9 hours ahead of Pacific. When it's 8 a.m. in LA, it's 5 p.m. I know this is all very useful, but it's just another way of representing value or data, if need be, in our table. All right. I know that's a lot, but let's move ahead. Let's talk about the interval data type. These store what we call elapsed time, or an interval of time between two date time values. Interval year to month stores a period of time measured in years and months. Interval day to second stores a period of time measured in days, hours, minutes, and seconds. All right, it's a data type, remember. So here, interval year precision, another name, to month. Year precision is the maximum number of digits in the year in this year element. The default value of year precision is 2. So we're going to create another example table. We're going to call our first column loan duration 1, interval year 3 to month. Loan duration 2, interval year 2 to month. So and we're going to insert values, loan duration 1, loan duration 2, where the interval is 120 month 3. And so basically 120 months from now. Interval 3, 6 year to month is 3 years, 6 months from now. So you're defining what the interval is, in case you're wondering. So once you insert these values here, and if you do a select with this indication where loan duration 1, cis date, so we're looking at cis date back March of 25, and you're asking it to give you the interval that's 120 months from now or 10 years from now. That was March 35, 3 years and 6 months from now. Yes, once again, another way to extract or display information based on an interval. And I have not used interval too much, if I can recall. But it's a way to represent, a projection or a prediction or whatever. So there you go. And remember, that's your default representation of your date. So interval day to second, use this when you need a more precise difference between two dates. So yeah, day to second. So you fine tune the interval to these values. So if you take a look at our next example, interval day 3 to second, interval day 3 to second, we have 2. We're inputting different values, or inserting, into day duration 1, day duration 2, interval, so 25 days from, first one is 25 days, and the second one is interval 4, and basically we're taking this time and actually creating an interval to the second as we are represented in our format here. Is this useful? And you'd have to determine if you need this type of precise data. Yes. If not, yeah, I don't know. It's just another way that you can manipulate data in your columns. Phew. So once again, a lot of useful information. A lot of it I have not used in my database administration days. are long past due, but I do remember the projection of the clob and the blob, even though they were not realistic, but they are now with the terabytes. Timestamp with time zone, timestamp with local time zone, and you'll get a chance to experiment with these interval data second interval data month. All right, moving right ahead. We're charging along. We're making good time. Our next topic is modifying that table after you created it. So our objective, explain, provide an example for each of these DDL statements: alter, drop, rename, truncate. There are different ways to modify your table. Construct a query to execute the alter table, add, modify, drop, explain and perform flashback query, pretty important. Explain and perform flashback table operations, and then track the changes to data over a period. Yes, you can do all of these. Explain the rationale for using truncate versus delete. Essentially important. 1 second. I apologize for the delays. All right. Add a comment to a table using the comment untable command. Yes, there's a way to comment on tables. Name the changes that can and cannot be made to modify a column. Yes, explain when and why the set unused statement is advantageous. A lot of stuff you can do in SQL. You're learning all this now. Okay, remember the statement. There's nothing permanent except that. That's just stupid. All right. Yeah, we're gonna go past that right quick. Wouldn't it be nice if we never made mistakes? Yeah, we all know this. We're all adults. We've made a lot of mistakes in our time. Up to now, we've created tables, made changes to the row data inside tables, but how do we make changes to the tables themselves? Very important question. How do we make changes to the tables? All right, alter table. The alter table statement is the one that you use to make changes. You can add new columns, you can modify an existing column, you can define a default value for a column, or you can even drop a column using the alter table command. So it is basically used to modify a table. So a newly added column always becomes the last column of the table, always. That's something in Oracle that you really can't change. I mean, you probably want to reposition it. And there's ways to use a GUI or whatever, but it becomes the last table. So also, if a table already has a row of data and you add a new column to the table, the new column is initially null for all that. So basically, if this column has data, or the table already has a row of data and you add a new column, then unless you add a default, and you'll see here, it automatically will contain a null value. So, all right, let's look at adding a column first. So alter the syntax, alter table. Yes, that's the start. And the table name, add, keyword add, column name, data type, and then if you want to use a default. And you could do as many columns as you want, one or more. So in our example, alter table, remember my CD collection, we're going to add a column and call it release date. And it's going to be a date, data type, and the default is going to be sys date. All right. And if we do a describe of my CD after that, we see we have that release date, all kosher. Let's alter that my friends table, add a favorite game column, varchar2, and you get the message. The table is altered, and we see the last column in that table is favorite game. Pretty straightforward. Column name, data type, default if you're going to use a default. Okay. You can also modify a column. So there's some rules to modifying a column. You can increase the width or precision, excuse me, of a numeric column. You can increase the width of a character column. You can decrease the width of a number column if the column contains only null values or if the table has no rows. So basically, if there's no data. or not data not defined. For varchar types, you can decrease the width down to the largest, basically the largest string that's in the column. If you try to reduce it or decrease it below that, then you get it. All right, you can change the data type only if the column contains null. So if there's data in there, you can't change the data type. So you can convert a char volume to varchar2 or convert a varchar2 column to char only if the column contains null values or if you do not change the size to something smaller. So basically, once again, it is slave to the amount of data that's in that column. The change to the default value of a column affects only the later insertion, so you won't impact the data that's already in there. That should make sense. All right. And here's an example of our column modification. So we're creating this table, mod imp with last name and salary. So I guess this is kind of a challenge. Which of these modifications would be allowed and which would not? Consider your answers both with and without rows. So let's just say there's no data in this mod imp. Which of these 1 through 4 would be allowed? You can type in the chat or unmute. So if there's no data, since you're not really chiming in, I don't think there's a problem with any of these changes, right? If there's no data, right? Does everyone agree with that statement? Oh, we got someone in the chat. Yes. Thank you, Valerie. All right. So if there is data, then we have to concern ourselves with the amount or the size of the last name, right? If we try to, if it's more than, and usually the last name is not more than 30. None of your names, or my name is not more than 30, but I'm certain there's names that are larger than 10. So this one would be questionable, the second one. And the numbers, it really depends. I mean, if you're storing yearly salary, it's not normally higher than 10 digits, but you never know. But if there's data and you're trying to set a default, you can set it, but it won't impact the data that's already in it. So that's what you need to remember about that. All right. And I think I cover that. So let's talk about dropping a column. So when dropping a column, yeah, of course, there's rules. You guessed it. A column containing data cannot be dropped or may be dropped. Only one column can be dropped at a time. You can't drop all the columns in a table. At least one column must remain. That's what I was getting to. Once a column is dropped, the data values in it cannot be recovered. So if you drop a column with data in it, it's gone. Yeah, you have to recover it else another way. Hopefully there's a backup. Usually you have to be very careful in dropping columns. All the things that I've done as a DBA, I've never dropped a column inadvertently that had data. And here's the syntax for dropping a column: alter table, your table name, drop column, column name. So we can drop those columns that we created earlier, alter table, my CD collection, drop column release day, and you see it's gone. Drop column favorite game, and it's gone. Simple, simple. All right. Moving ahead. Set unused columns. All right, dropping a column from a large table can take a long time. Well, that's a large table as an amount of data. A quicker alternative is to mark the column as unusable, which means you're not dropping it. You're just saying you can't use the data that's in this column. The column values remain in the database, but cannot be accessed in any way. And that's kind of an Oracle thing. That's pretty new. In fact, you could add a new column to the database with the same name, once you've set a column unused, if for some reason you want to do that. The unused columns are there, but invisible, basically invisible to someone trying to query that table. And the way that you do that, the syntax is alter table, table name, set unused, and then you put your column name. Straightforward. And here's an example, copy of employees, set unused email. Yeah. And you can also run the drop unused column, removes all columns currently marked as unused. So you can set it unused and then drop it if you need to. So use the statement and you want to reclaim the extra disk space. Yeah, basically you want to, although reclaiming extra disk space is not such a big deal anymore. But so set unused and then drop unused. Drop unused drops the column. All right. All right, here's a summary, and you can review this. All the particular attributes or properties per se of altering a table. Add a column, modify a column, drop a column, set unused, drop unused. Before that we just covered. Okay. All right, now we get into the table itself. Yes, you can drop a table. If you run the drop table statement, it removes the definition of the table. The good thing, the database loses all the data in the table and all the indexes associated with it. So when a drop, so I was going to say good thing, but I'll get to that. When a drop table statement is issued, all data is deleted. The table's description is removed from the data dictionary. Not such a good thing to do if you're not sure. And the Oracle doesn't give you a chance to, are you sure it? It just drops the table immediately. I think that's one of the things that's been tossed around quite a bit. So, yeah, what was I thinking? All right, I'll get back to that. So in the next slide, you'll see that you may be able to restore. That's what I was going to talk about, the table after this drop. But it is not guaranteed. That's even now, it's not guaranteed. It's cleaner, but not guaranteed. Only the creator can drop, and usually it's the DBA. Generally, you don't have, in your regular company database, you do not have the privilege to drop a table. You'll get an error message, no privilege. So the syntax is just drop table and the table name, simple as that. And there's an example. All right, so you're saying, well, what if I drop the table by mistake? Yeah, well, there's this thing called flashback table. So each database user has what's called a recycle bin, and you know that you can restore things that you've deleted or placed in the recycle bin, and the flashback query is just that type of scenario. So the syntax is flashback table, table name, to before drop, and it'll actually, and it's pretty, pretty clean as for the most part. When you run a flashback, with these new databases, structure systems and schema, yeah. The flashback table will work. So essentially, because it actually has a recycle bin, believe it or not, and in the data dictionary, you can look at something that was dropped just to make sure that if it's flashback, you will get what, basically you'll get the data and the structure of the data without any issue. So if you query the recycle bin, basically there's several columns, but if you do original name, operation, drop time, you can see the operation on the tables, et cetera. If it's deleted, there's a lot in there, and you'll get a chance to take a look at that. So obviously, once you use a flashback table, it's no longer in the recycle bin. It may be necessary for security reasons to completely drop a table bypassing the recycle bin. And so this can be done with the keyword purge. So drop table employees and just use purge and it's gone. And now that table can't be recovered. All right, enough of that. Let's say we want to change the name of the table. Well, we can use what's called a rename command. And it's rename old name to new name, just that simple. Rename my CD collection to my music. Table rename, and now, yeah, pretty easy. Easy, yeah, good stuff. Truncate. Truncate a table removes all rows from the table and releases, basically, it clears all the data, but it doesn't delete the table. That's the difference between drop and truncate. So when using the truncate, you cannot roll back, basically you can't recover. Well, generally, let's see, that's the big thing. So truncate table name is the syntax. The delete statement also removes the rows from the table, but does not release the store. So that's the difference between truncate and delete. Truncate releases the storage space, so it clears out memory, et cetera, and all that stuff. Where delete doesn't, it just deletes the data. And because it does not generate, truncate is faster because it does not, than delete because it does not generate rollback information. Delete generates rollback information. So please remember that. Whew. Moving ahead, comment on table. You can add comments up to 2,000 characters. Basically, if you need to add comments to a table, and I'll show you how to access that. The command is comment on table name, and then column table.column is, and then you place your comment here. So comment on table employees is Western region only. That's basically adding that. So this is saying you can call the table name, the column, or the table column, add the comment to that particular part of that entity. All right. All right, so to view the table comments in the data dictionary, you run the query, select table name, comments from user tab comments or user table comments. And you get to see where the comments, so we just added that. Western region only. So if you want to drop a comment, yes, it's comment on table. If you want to drop a comment previously made on a table or column, you use the empty set. I know that's kind of ridiculous, but comment on table employee is, and then just an empty set, and it'll get rid of the comment. That's awkward, but that's kind of the way that relational databases systems work. So commenting and removing the comment, very awkward way. Oh, we did talk about the flashback. So you may discover data in a table that somehow been inappropriately changed. Oracle has a facility, yes, that allows you to view, basically view how the data has been changed. It can be very useful. You can basically, look back and say, well, that was changed, and I don't think that that's correct. You can use the flashback query to examine what the rows look like before those changes and after. It basically keeps a record of how things have changed. And these old copies can, basically they're good because you can undo some of the changes. That's essentially what we're saying here. So it actually creates versions of basically your data changes. So take a look at this query. This one is a little complicated, but it's kind of the way to look at operations on a table. So we're selecting employee ID first name, concatenating that with last name as name. So conversion operations, so anything that occurred on those columns, the start time, the start date, the end time, the end date, and then salary. And this basically, you're indicating the versions of those changes. And the SEN number referred to in the above means that the system change number, and it's basically the precise identification of time. It is a sequential number incremented and maintained by the database itself. And the best way to demonstrate this is with an example. The contents are as follows: employee ID 1 in the employees table. So we're going to insert a kind of a arbitrary new value into our employees table. This one, Natasha Henson, email, well, for 1-2, that looks like a phone number. Sys date, hire date, et cetera, et cetera, et cetera. And so if we take a look at what we just ran as far as a query, we know that this person was added on that date, no end date. So you can basically, and the I in here is the operation, which means an insert. So you can actually track the process of, and use the flashback query if you wanted to change something back to a previous version of it. And here's another example. We're using the same, we're looking at King because he's employee ID 100. And you can see basically he got to change the salary. And so you're just tracking events. Does that make sense to everyone? Yes, and the way this is constructed, I mean, this generally you would have to, well, hopefully you understand the whole versions. Versions, operation, version, start time, and end time, basically when it started, when it ended. All right, here's another aspect of the flashback scenario. I know this is a lot. So you can actually run a command, and this is the only way that you can do this, at least it was. I'm pretty sure it hasn't changed. You run the command alter table, enable row movement. This is basically saying that we're enabling our record to be manipulated. It's just a way that we can use the flashback to, possibly, and I think we're going to go through this. Oh, I guess I eliminated that. If we want to return certain values, although you would run this query. Let's say King got demoted and you want to return his salary, you would actually do an update and things like that. So, all right, another bunch of information that you'll be able to practice on. There are key terms in this topic: alter table. Something in the chat. Diane asked, can you reverse making a column unusable? You asked that way long ago. And let's see. Oh yeah, well, no. Once you make a column unusable, you either drop it or recreate it. Yeah, drop is the only command that you can do after you make it unusable, which is very odd, but that's generally the case. Okay, Diane, go ahead.
Yeah, so when you say you either drop it or recreate an unusable table, does that mean there's like a convenient way to just like import that data from that column again into a new one?
No. Well, no,
Oh.
unfortunately. That's kind of an odd restriction, but that's why you have to be very careful with your column data. If you're getting into the drop, you need to have a reason for it. There's suspicious information or whatever, and maybe you're testing it, and then eventually you're just going to drop it.
Oh, okay. So, for the unusable column, like how would you, I know you said it's invisible, so would you even be able to see the data to like manually copy it?
Well, when you say so generally, it's not something of a scenario like that because you may be thinking about thousands of rows. So either you're creating, importing, or doing something different to bring that data back for some reason, or you run it. You've done something external to the column itself to ensure that the data integrity is there. But once you make the column unusable, then you have a reason. if you're setting it on use, then you have a specific reason for that.
Okay. For me, I when you were explaining the concept, it seemed like it was like a safer alternative than like dropping it, but it sounds like it's pretty much just the same. You're just like you're done with that info, I guess.
It's kind of a temporary drop until you completely drop it. Now,
Mm.
there's been some changes to that particular function. So I know that I've never used that. It may not even be, I thought, I mean, if you set it on use, you may be, because your question is, can you just, reverse that? And if my memory serves me right, no. Because you're just preparing to drop it.
Oh, okay. Huh.
But
That's good. It sounded really cool, like to temporarily like lock data to not be like referenced, but
yeah,
yeah.
that would make, you're being too logical, Diana. That would make more sense, but
It's just like a weird like right before dropping it step. I don't know how to use it yet, but I guess I will. I also had another question.
yeah,
So like truncate is more permanent in a sense than delete because there's no rollback.
right. Because it basically prepares that all the data goes and it's not even setting it up for it removes all the storage space essentially that the data had taken up. And that's usually another one of those things that you have to be very sure uh,
Hmm.
to use that versus delete um, because now, yeah, you can run a flashback, but yeah, that may not, especially if you truncate the table, that may not work.
Okay. Okay. So does drop generate like rollback info?
Yes,
Okay.
yes, you can definitely flashback a table from a drop. From a
Okay.
truncate, it's a little bit more iffy.
Okay, got it. And so on that like last lesson you talked about how you gave everyone like a raise or whatever. Were you
Yeah,
able to flashback that whole thing or
that was not a table. That was an update. It was an update,
oh, right to the data.
and this was old. Wasn't even Oracle. This was old database where there's no such thing as. We just had backups, and so and the backups were very very not stable. I should say even then because I was converting the database. So this all that you're seeing now is
Mhm.
probably in the last 10 years that's more prominent. Back when I did that, which is in the 90s, I think. Yeah, there was no way to well, I shouldn't say that. We were able to recover it. It took us about a week to do that. But in the interim, because I did that right before a payday, everyone was like jumping up and down and you know. Of course, there's the way that the system worked, we can't just ask them to give the money back. So it didn't really matter. It was one of those scenarios, if I remember
Oh,
correctly.
that's so crazy because I like heard that at CGCC they accidentally paid a bunch of people more and they like my previous professor was talking about this and he said they did ask him for the money back.
Yeah, and yeah, yeah.
But
Yeah, I don't remember if well, I was buried, I was a DBA, so I didn't care. All I care was about the processes, and I was told, uh, because I mean those cues were sent to whatever the banking institution and the money was distributed. So then it becomes a university. Maybe they did, I just don't know of it. I know that I wasn't a part of it. They probably asked them to give the money back, but
interesting. Okay, I had one other question back to unusable columns, but I was wondering if you could still like somehow at least see that they're there because if someone forgot to completely like delete them, would their table be like, could it be possible for a table to take up a lot of space and you not know why if it's
right.
like columns you can't see or some
Yeah,
kind
and
of
that's what you would use the data dictionary. You would investigate what properties of that table still exist, if any, because you can find that because the data dictionary, and you'll see it's quite robust as far as information about the objects, everything about the tables, everything about um, the columns, etc.
Oh, okay. Thank you.
Yeah, welcome. Thank you. All right. So, all right. Believe it or not, that's the end of part one. We're going to segue right into part two. So that's primary DDL, data definition, basically the way to change your tables. In our next section, we're going to go into constraints. We talked about constraints a little bit, but these are special types of constraints. And usually many of these constraints are set long before you even impact the table or access the table by the DBA. And basically, the constraints are used to ensure data integrity, big time. So we're going to learn when it's possible to define a constraint at the column level and when it's possible to define it at the table level. Basically, why do we need meaningful constraints? Remember, this is all data integrity. And then say which data integrity rules are enforced by not null and unique constraints. And then write a create table statement with not null and unique constraints. These are constraints, and you'll see what I mean. And explain how constraints are created at the time of a table creation. So we talked about creating a table, but there are specific constraints that you need to be aware of even when you're creating the table. And here's our reasoning, talks about society, rules, blah, 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 traffic lights. Without rules, there's chaos, blah, blah, blah. We know we have foreign key, primary key, connections, which talks about constraints. So what do you think would happen to a database if these rules were not enforced? It would be anarchy. And believe me, when I came up through the database administration ranks, it was all about, we have no control of what's going on. So hence the whole idea of constraints. We had data which was not usable, et cetera, et cetera. So would it make sense to have negative salary values or 6 students with the same student ID, blah, blah, blah. These are just general reasons why there's some rules of data integrity, which some of them you probably don't have to worry about, but many of them you need to understand why they're there. And so this is what we're going to get into. So what exactly is a constraint? So think of a constraint as a rule. It's a database rule. All constraint definitions are stored in the data dictionary, and you'll see constraints prevent the deletion of tables if there are dependency. We saw this before, right? With our little assignment, we saw that we couldn't arbitrarily delete a department. And this is because of the constraints. So now you get to see why. So constraints enforce rules in the data whenever a row is inserted, updated, or deleted. There are 5 types of general constraints that we need to consider, not null. And you can kind of figure that out. The values in that column cannot be null. Unique, like our indexing and our primary key, or another column, and then primary key, foreign key. And then there's a check constraint. Check constraint is very important because you can use it to check the data to make sure that if there's data entry, et cetera. Constraints are important, so naming them are important too. So you can name a constraint 1 or constraint 2, and that would actually not be good. So I mentioned the naming convention when creating table. You want to think of constraints being the same probably the same thing. All right. So you do use the create table statement to establish constraints for each column in the table. Right. So there are 2 different places in the create table statement that you can specify the constraint details. At the column level, next to the name and the data type. At the table level, after all the column names are listed. And that's the difference. You'll see that on an exam. So here's an example of constraints being created at the basically, well, we're going to get to the constraints, this is just a table. We're creating a table called client number, first name, last name. Simple, simple. Note that the column level simply refers to the area. Yeah, we saw this before, so we're just reinforcing that. Let's say we wanted to add a column level constraint on that client number. We want to add the constraint, and we're going to call it constraint. And yes, this is one syntax, and yes, you can get away, and I'll tell you this right up front, with just putting primary key, and it automatically becomes a primary key constraint. But we're naming the constraint so that we can identify it later. So this is correct. Constraint clients, that's the name of the constraint. Client number, PK, primary key. Does that syntax make sense to everyone? I need to start you out with a question right away. All right, good. So this establishes a column level client number column constraint. And that's the name, and yeah, that column. All right. All right, so every constraint in the database has a name. So we just named this one, and kind of remember this naming convention: table, column, type of constraint, client number. That, please, as much as possible, follow that naming convention when you're creating your constraints. It makes it easier for anyone else looking for constraints to disable or enable, etc. And you'll see that later. So it's best to name the constraints yourself, because system generated, this is a system generated constraint here. So this is why we're suggesting that you name yourself table name, column name, etc. I just went over that. So if we look at this table again, let's say we add, if we want to add different constraints, and please take a note of these. We have 3 different constraints on those three columns. We have a primary key constraint that this column cannot be null, and another constraint, which is usually associated with email, that this column has to be unique. And notice the naming convention: table, column, NN, not null, table, column, UK, unique. Make sense? All right. All right, so, and I mentioned that, there's system level constraints, or system name constraints. Primary key is one, but we're using this syntax to name that constraint. And you could just simply say not null. That is a system accepted system name constraint. You just won't have a name like this with it. There'll be some system generated name if you're looking for that constraint, but that is an accepted syntax for not null in your last name. And you see that mostly in primary key as well. So please remember that. And I talked about that before. Just make it, this is acceptable, but when you're looking for that, you may see something completely different as far as the naming convention, which is why we suggest you name them yourself. All right, so we just witnessed column level constraints. There's such a thing as table level constraints. They're listed separately from the column in your create table. The table level constraints are listed after all the columns have been defined. So we got client number, first name, last name, phone, email. And then we have the keyword constraint after the columns, after the comma. The name of the constraint is unique. And we're actually making 2. Notice we have 2 columns here, because we can list the columns in the parentheses here in our constraint. Remember, that's a close parentheses for this. But email and phone, we want to make sure those are unique. So, and that's one of the reasons why we would want to make this a table level constraint, because we can use invoke that constraint on both of those columns. Okay. And notice the naming convention. And so just to make sure you understand, a constraint that will involve more than one column will always be a table level constraint. All right. That's one of the rules. The not null constraint can be specified only at the column level because basically that's one column at a time. Think of it that way. Unique primary key, foreign key, check constraints can be defined either at the column or the table level. So if the word constraint is used in a create table statement, you must give the constraint a name. So if you have the word constraint, you have to give it a name. All right. If you don't have the word constraint, it has to be one of the accepted system constraints that's already predefined, like this not null here. Okay. All right. What's wrong with this query? You're supposed to examine the violations. What's the problem with this query, with the constraints? Anyone want to point out one? All right, here we go. So we have a composite unique key violation because we have a table level constraint, or we're trying to force a constraint that should be table level on it, column level. That's this one here. We have a naming violation. We have constraint and no name. And then we have a not null at the table level, which we just said it has to be at the column level. Does everyone see that as far as issues with this query, create table query constraints? Thumbs up. All right, a column defined with the not null constraint requires that every row. So basically, not null is important. That means that if there's data in that column, or you cannot essentially update that column, well, you can't have null in that column. I mean, that's enough said. If it's listed as not null, it has to have data. The unique constraint, all the values have to be unique. If there's any type of duplication, you get an error. Constraint violation. We all know what the term unique means. Like emails have to be unique. Phone numbers are usually unique too, unless you have an employee that has the same phone. And basically, you can identify more than one columns, and if for some reason you want to have a complicated key, for example, and we're going to talk about this a little bit later, but if you want to make sure that, because you may have employees that have the same name and you want to ensure that there's a unique combination, then you can use the unique constraint across multiple columns, which it has to be a table level constraint. Just remember that. Here, and here's an example. And basically, if you kind of read through this, we have a unique constraint on email, correct? And let's see, Lauren Vigil worked for the company, and then we hire Lauren's husband, Lonnie Vigil, and their emails are the same. Well, they both have access. So you would have to, if you try to add that or insert Lonnie, you'll get a unique constraint violation. So what you would probably do is create a multi-column constraint at the table level. This way, clients phone and email. And so that way, since the phone numbers are different, now we do not get that error. you'd have to go back and change that so that that constraint is, you move it from the column level to the table level. And now both Lauren and Lonnie can work for us without any problems. Yay. All right, we call it a combo. Well, it's two columns to create a unique. We call it a composite unique constraint. All right. So generally, if you use a not null constraint as a part of your table creation, Oracle will create a check constraint, which, and we haven't talked about that yet, but basically it's checking to see if there's values in that particular column. Now, all I want to cover here, you have to remember that a check constraint is a way that you can essentially check your data so that you don't run into a constraint violation. So that's, and I think we're going to cover check constraints a little bit more here. But all right, take a deep breath. We have a couple more topics to go and we'll be done. Check constraints, column level, forward key, not null, primary key. Remember, those are automatically constraints. Table level constraint, unique constraints, and unique key. All right. Primary key, primary forward key, and check constraints. I told you we're going to cover it. So define and give examples of primary key and forward key constraints. And check constraints. Explain the purpose of defining primary key, foreign key. Demonstrate the creation of constraints at the column and table level again. Evaluate a business problem requiring the addition of a primary key and foreign key, which you often run into with database manipulation. As discussed in the last section, constraints are used to prevent invalid data entries. What would happen if surreptitiously or just through a careless mistake, your personal unique identification was given to another person? Happens not that often, but it can happen. What if tomorrow at school someone else was credited with your class for graduation or was able to eat lunch using your lunch card? Do we have lunch cards anymore? Sorry. Ensuring data integrity is very, very important. I don't think we have lunch cards anymore. All right. So a primary key constraint is a rule that the values in one column or a combination of columns must uniquely identify. So basically, it's a way to identify a record, which is the primary purpose of the primary key. So primary key values can appear in more than one row in the table. To satisfy a primary key constraint, both of the following conditions must be true. No column that is a part of the primary key can contain a null. The table can have only one primary key, meaning one primary key, whether it's a combo key or just combo key or just one column. All right. So primary key constraints can be defined at the column or the table level. However, if a composite primary key, which is more than one column, that has to be at the table level. When defining a primary key column, is good practice to use the suffix. We just went through this, and that naming convention should always be prevalent. And we saw this in our little table. So, and yes, you can use just the keyword primary key, but remember, you won't have a specific name for it, which is why in some scenarios, you're naming that primary key. All right. And if we wanted to do it at the table level, that's the syntax or perform it. And we're identifying the client number as a primary key. If we're identifying a composite primary key, which is two or more columns, here we're looking at ID and start date composite. So employee ID and start date. That becomes a composite primary key constraint, which you see often. Right. Foreign key constraints are also called referential integrity constraints. We've seen this before. Foreign key constraints designate a column or combination of columns as a foreign key, and basically they have to be referenced by a primary key. That's the whole purpose of it. Whoops. The table contains a foreign key is called a child. The table that has the primary or reference key is called the parent. Like our employees with departments, you see that, and I know we know the relationship there, which is that is generally the very distinct way that we define the relationships between tables, which makes them a relational database model. I mean, it is a basic premise way back to Stevens when he started this in the 50s. So basically, to satisfy your referential integrity, you have certain values that are corresponding, and see the uniqueness in our parent table, but it doesn't necessarily have to be unique in our child table, because with the departments we have several employees or several employees in each department, etc. All right. Oh, that's Diana's question. All right. All right. This further explains essentially the relationship between your primary and foreign key and why the uniqueness in your primary, etc. Just summarize that. So basically, you must have a primary key before you create a foreign key. And once again, to define your naming convention, use the suffix FK. And here's another example of defining a foreign key that references, and you have to actually use the term references. And please make a note of this syntax. Department ID is a constraint that references CIMP's department ID foreign key, and it does have underscore there, you just don't see it. Department ID in the departments table. Yep, that's your child. And if we saw the other table, you'd see your primary key. And this is that's at the column level, this is at the table level. Okay. All right. So speaking of referential integrity, there's this command on delete cascade, and we're moving from where we can't delete like a department because there's referential integrity there, foreign key. So there's a command, if the foreign key does not have an on delete cascade option, then basically you can't, essentially you can't delete it. Because if you're trying to delete it, you're destroying the referential integrity. And simply you can change that by adding this on delete cascade. So we saw this relationship here. In order to ensure that we can delete, we run a query that looks like this. And basically, we're setting up our primary key, foreign key. And then what we would do, and that's off here, we would add, well, this is just showing if we try to delete, we would get a referential integrity constraint violation. So what you need to do when you're creating this foreign key, at the very end of our constraint, we would place the term on delete cascade. And so after we do that, we can delete any of the dependent rows because it'll basically remove the referential integrity. Right. Another way of ensuring that you're not impacting the integrity of your data is use the command undelete set null. So instead of deleting it, it'll just set the value that's housed in that child table to null. And then you can do whatever you like with it. So those two are undelete cascade and undelete set null. And they basically will follow the creation of your foreign key constraint on the child table. Okay. All right. Check constraints. Check constraints explicitly define a condition that must be met in a column. So here we're creating a check constraint on this date. And basically you're saying that the end date has to be greater than the start date. You would think that people would not, generally perform the right actions there, but you're ensuring that they can't, make, something not appropriate for that particular content. So it is a constraint, and we call it a check constraint. So a check constraint must only be on a row where the constraint is defined. The check constraint cannot be used in queries that refer to values in other rows, so just the row. Check constraint cannot contain calls to the function sysdate UI user ID user or user in. The statement check sysdate is not allowed, so you can't check the sysdate. Sysdate greater than, would not make sense in most scenarios. So cannot be used in pseudo columns, current value, next value, level, or row num. The statement that's not allowed. A single column can have multiple check constraints. Yeah, that references the column in its definition, and there's no limit of check constraints that you can have on a column. So you can have that column locked down to exactly what you need that column to do. And this is basically the column level syntax. Employee minimum salary check. The salary has to be greater than 0. Pretty straightforward. Table level, after all the columns are defined, same. Right. Okay. So we learned check constraints, what they are, foreign key, references, not null, undelete, cascade, undelete, set null, primary key constraint. All right. Our last topic, I know it's been a lot. Thank you all for bearing with me. This is probably the heaviest module that you'll have for the whole course. All right, managing constraints. That's 4 different functions that alter statements, that the alter statement can perform on constraints. But an alter table statement to add, drop, and disable and enable. Yeah, you can disable and enable constraints. Name a business function requiring a DBA to drop, enable, or and that's usually the case where constraints are impacted. And then query the data dictionary to take a look at your constraints. A database system needs to be, you need to enforce business rules. That's the one thing that does, even if you're an analyst, you do need to know the business rules that are centered on data. We're going to learn about some of the things that you need to do. For example, if you have a merge or something like this, then you need to import lots of data. You may have to change constraints. All right, what do we do to manage constraints? The alter table statement is used to make changes. These changes can include adding or dropping, adding a not null, whatever you need to do with the constraint. Simple guidelines. You can add, drop, enable, or disable constraint, but you cannot modify its structure. Remember that. Add, drop, enable, disable. There's no modify. You can add a not null constraint to any existing column by using the modify clause of the alter table. Modify is used because not null is a column level change, okay? You're going to find a not null constraint only if the table is empty or if the column contains a value for every row. So it's either empty or it's all full. All right, so here's the alter statement. So what it requires: the name of the table, name of the constraint, type of the constraint, name of the column affected by the constraint. That kind of makes sense. So in this code example, alter table employees add constraint. We're adding a constraint. Primary key employee ID. In the code, using employee tables for primary key, you could have been, well, this basically we're saying that the employee tables did not have a primary key. We just added it later. So that's just kind of a basic example. We already have a primary key on our employees table. All right, so to add a constraint to an existing table, use this syntax. We just saw an example of it. Add constraint, constraint name, type of constraint, column name. So alter table, table name, add constraint, constraint, yes. Foreign key references, yeah. Foreign key is always a little bit different because it has to reference a primary key. All right, there's our table, our employees and department table. If we wanted to alter that constraint, if we wanted to add a foreign key, if it exists now, but if we wanted to alter it, and let's say we wanted to add the on delete cascade, we would do it that way. Because it's not there now, which is why you couldn't delete the departments. Okay, that's how you would change that constraint. Okay. All right, to enforce the rules defined by integrity constraints, the constraint should always be enabled. So yes, you can disable constraints. In certain situations, however, it is desirable to temporarily disable the constraint. You do have to remember that you did that. And yes, when you're loading large amounts of data or changing, and there's a lot of batch operations that occur. I had mentioned before, like mergers. So you may have to go in and just disable temporarily a constraint. Oh, that's a repeat. I have a repeat slide in there, sort of. What did I do that for? Anyway, I need to check that. Why? So why enable and disable constraints? Yes, for those particular reasons. Usually, in my experience, large amounts of data is a part of the process. All right. And we're going to talk about enabling or disabling. I don't know why I'm skipping over this. Maybe I need to. Hold on a second. This is all out of order. Yeah, maybe I should have checked this before. All right, we'll get to this. So sorry about that. All right. So there's reasons to disable it, enable. By default, whenever it's designed, it is enabled. So to disable it is a simple command. Oops. So alter table, disable constraint, and then the name of the constraint. So that's how you disable it. And yes, to enable it, it's enable. The name of the constraint. All right. You can drop a constraint, and yeah, I'm jumping around just to keep you awake. So to drop a constraint, you need to know the name, and you need to make sure that the on delete cascade option is enabled. And it's another alter. and it's just drop constraint in the name. And then cascade, which we'll put in that cascade basically to ensure that you're not impacting. I know it's a big deal. And we talked about that. The cascade clause disables, basically it disables the dependency. Okay. So that's why you simply use cascade when you're disabling a constraint. So it will disable all of the integrity, referencing integrity. And yes, I'll have to change the order of this, but if you disable a constraint to enable it or re-enable it or check to see if it's enabled, the syntax is just enable constraint and then the constraint name. Okay. So if you enable a constraint, yeah, and it applies to all the data, and all the data must fit the constraint, or else you get another constraint violation. So you have to be very careful for that. But usually you have a specific reason, but you may have to check the data after you disable to make sure it matches. That can be a headache. I've run across that before. All right, so this cascading, it basically allows you to define everything without impacting the, just remember, it's all about the referential integrity. If that's enabled, you don't have to worry about impacting the integrity. And basically, these particular scenarios, if you need to change large amounts of data, you need to ensure that that's all in place so you can make your changes, and then you may have to check a couple of things, but more than likely, you're just going back and ensuring things like not null or unique, make sure that they're satisfied. That can be a problem. And here's the syntax for creating the, if you want to drop the column or column names, basically, once again, if you're using, and this is the way to prevent what we were running into before, we needed to delete a department where there was referential integrity. We just cascade all the constraints. That way they all go whoop, and they're gone. This is not required. As a matter of fact, if all columns referenced by the constraint defined on the drop columns are also dropped, so you're dropping all the columns, then you don't need the cascading constraints. It's usually when you're dropping columns from your child table or any type of targeted table that has the referential integrity that you need the cascade constraints clause. With that said, yes, you can view your constraints that are on your tables. Yes, that's in a data dictionary. So to view all your constraints, you simply select constraint name, table name, constraint type, and status, which is going to be enabled or disabled from user constraints. Yay, or table name. So here are all your constraints. Currently, it gives you the table, the type, check constraint. Geez, I forgot all the letters. Unique, primary. What's R? You can tell me what R is. What's R constraint? I should know this. We're all inundated. Oh, here we go. R is reference, like a foreign key. So it's a foreign key. P is primary key. C is check. And U is unique, including null, including not null. All right. Woo-hoo. Right, that's constraints. And this is managing constraints. Here are key terms. Alter table is used. That's what you use to manage your constraints. Cascade clause, cascade constraint clause. Disable. Drop column, drop constraint, enable constraint. Woohoo! Believe it or not, that's all the lecture material. And you're like, oh, we've had enough. Spare us. All right. Let's take a look at what's happening this week. All right, once again, I'll post our lecture material there. There's several videos. You probably like, think I've had enough, but there are only a few there for you to go through. There is a section here that comes from Oracle on import and export of data. I would read through this. It is useful information. Just click on, it'll take you out to the current importing and exporting Oracle. Useful information. You may see this in the final. So I would definitely go through that. And then you have your practice queries. Yes, there's a ton of them. And it covers all that we talked about, DDL and constraints. Yes, there's a ton of them. I'll say again. Always useful. And then your practices, yes, once again, there's a lot. So 11.1, 11.2, 11.3, 11.4, 11.5, 11.6. I do separate them. The first part is DDL, and I'm not allowing it to to finish its rendering, but you've seen these before. They're just like your assignments. Yeah. So my system is very slow today, but anyway, we're not going to wait on it. Then 4, practice and solutions, 5, and this is all the constraints, and 6. Okay, and working my computer too hard. All right, and then as far as the assignments for this week, you do have 2. One covers the DDL, basically tables. I'll wait for this to render. And this one's not too bad, just 5 questions. Yep. All right. Not too bad. And then the second assignment, eventually. Oh, great. Great. So let's just download it. Probably best to download it anyway. That's a little bit quicker. I was supposed to looking at the preview. See, these aren't too bad. I mean, there's really only 2, 3 in assignment 2. So altogether, it's really not that bad. So no panic is not necessary. I'm not inundating you with far too much work. And then your quiz, and the quiz does cover creating tables, user data types, or using data types, modifying table, and then your constraints. So, and that's it. Not too bad, right? You're like, really? This person is crazy. All right, so yes, this is a heavy lifting week, and I've lost a lot of people. That's all right. So 2 assignments, 1 quiz, done for the week. Module 12 is back down to kind of a normal module. Yes, we will meet next Monday. Yeah, I'm sorry, Diana. I think, yeah, that is a hurt your brain lesson.
It's okay.
So we will meet next Monday. I promise it's not nearly going to be this long, and that's Thanksgiving week. So hopefully you're going to relax and just enjoy your being thankful. And then we're really pretty much done. A couple weeks and we're done after Thanksgiving. So think of it that way. And yes, there's a final pending, but we'll talk about that later. I don't want to blow up your heads anymore. All right. That's all I have for this evening. I know it was a lot. I'm sorry. We had to have 1 week like this. So Take care. I will see you all next week.
Thank you. Bye.
Thank you.